Hi guys, I'm D. Sumanth here from VIT University Chennai campus. I'm here to help you guys to solve some of the fundamentals of electrical circuits problems. And so basically I have taken for AC circuit analysis, and here's my name, D. Sumanth, 16 BEC. So coming to the first question, solve for all unknown current and voltages. In this the circuit we have two current source and four resistors, and it's grounded to the circuit. So explaining thing has the question has given I1 is equal to 10 mA, I2 is equal to 50 mA, and R1 is equal to 1 kilowatt, R2 is equal to 2 kilowatt, R3 10 kilowatt, R4 is equal to 2 kilowatt. And using the KCL, you know what is KCL? Actually, KCL is current, Kirchhoff's current rule law. And using KCL in this thing, I1 minus V1 minus theta. We take this as V1 and this as V2. So you get I1 minus V1 minus theta by R1 minus V1 minus V2 by R2 minus V1 minus V2 by R3. And we can rewrite these equations. After rewriting the equations, you get I by R1 plus I by R2 plus I by R3 V1 plus minus I1 by R2 minus 1 by R3 V2 is equal to I1 at node 1, and doing the same thing at node 2, you get this equations. After getting these two equations, when you substitute these values in these equations, you get the corresponding equation as 1 by 6 v1 minus 0.6 v2 is equal to 10, and minus 0.6 v1 plus 1.1 v2 is equal to minus 50. Solving these two equations, you get v1 is equal to minus 13.57 volt and v2 is equal to minus 52.86. If you know the voltages, you can easily find the current by using the Ohm's law, that is V is equal to IR. So by doing that thing, you get I is equal to 3.93 mA, and I is equal to minus 13.57 mA. So that's the answer for the first question. Coming to the second question, write the nodal equations and solve for node voltages. It's given in this question. It's given solve for node voltages 2, and in this thing you have two current source and four resistors. Applying KCL. Okay, first let us assume the node. This is node 1 and this is node 2. Applying KCL to node A and node B, I1 is equal to, we're taking this as IA, that is IA, minus VA by R1, VA by R1, minus VA minus VB by R2 is equal to 0. And for the node B, again VA minus VB by R2 here plus IB, this current, minus VB by R3 here, and minus VB by R4, and you get these two equations. Rewriting these equations, we get as 1 by R1 plus 1 by R2 into VA plus minus 1 by R2 VB is equal to IA. And for this equation, you get that minus 1 by R2 into VA plus 1 by R2 plus 1 by R3 plus 1 by R4 into VB is equal to IA. And you substitute the R values for all thing, you get 3 into 10 to the power minus 3 VA minus 2 into 10 to the power minus 3 VB is equal to 1 into 10 to the power minus 3. And for this substituting, you get this answer. And solving these two equations, you get VA is equal to 1.667 volt and VB is equal to 2 volt. And we go into the third question. In this question, voltage source is given and current source also. Voltage source is given as Vx, and the current source value is given as 0.5. Okay, in this question they're given the given values, so it'll be easy for you to find out. And again in this question you should use KCL. Applying KCL to node V, that is node V is this, Vx minus V, Vx is equal to this, Vx minus V, Vx minus V by R1 plus I, this I, minus V1 1 minus V3 by R2 is equal to 0. That is node V. Applying KCL to node V3, you get V minus V3 by R2 minus V3 by R3 is equal to 0. And these two equations you get 1 by R1 plus 1 by R2 V plus minus corresponding equations. And again, as usual from the last question, you should solve these values in this equation and you get these corresponding equations. And when you get these two equations, when you solve this, you get the values V is equal to 5 volt and V3 is equal to 3.33 volt. That's it. The third question is finished. And now we go to fourth question. In this thing, they asked to compute the open circuit voltage. That is VA. This is open circuit. It's open. That is so. This one is open circuit voltage. And in this we have one voltage source and four resistors. Again, same as usual, we should use KCL rule. And this 12, we assume this as V1 and this is VA. 12 minus V1 by R1 minus V by 10 minus V minus VA by 10 is equal to 0. And VA minus V minus VA by 10 minus VA by 20 is equal to 0. And when you put these two equations in the matrix form, you get 1.2 minus 0.1 minus 0.1 0.5 VVA 12 0. And solving these two equations, you get V is equal to, it's quite simple. uh, and in this question you need to coming to northern equation. First of all, we should understand one thing. Northern equation, in northern equation you need to find two cases. One is RTH and VTH, that is similar to Thevenin's. In RTH equation, first you need to open circuit the current source and short the voltage source. In this we have only voltage source, so just short circuit it. If you have current source, you should open circuit it. uh, when you short this thing, this 8 V1 8 minus 8 will go off, and so you have 1 2 3 4 resistors alone. Then 5 into after solving this thing, 5 and this 5 and these 3 are parallel, so 5 into 11 by 3, solving these 3 we get 11 by 3. When these two are parallel, by using you know how to do parallel thing, so 53 by 3 by 26 by 3, 50 and 3 3 will get answer. 55 by 26 equal to 2.115. So this thing is a ZTH. Now finding the VTH, you should take three loops: I1, I2, I3. For I1, you get as 9I1 minus 3I2 minus I3 is equal to 0. And for I2, you get as minus 3I1 plus 5I2 minus 2I3 is equal to 0. And for the third equation, you get minus I1 minus 2I2 plus 3I3 is equal to minus 8. When you solve these three equations, you get the values I1, I2, I3. Quite straightforward question. And I think when you solve this, you should be able to solve in calculator, which is very useful for you in the time of examination, which is quite easy to. And now coming to the sixth question, and here what I'm coming to say, this is Thevenians. Yeah, almost Northern and Thevenians are almost same. And the thing we should find ZTH, even here ZTH, VTH, VTH, everything is almost same in these two questions. And here we have V1 is equal to 36 volt, V1 is equal to 36 volt, and four resistors. As I said, ZTH, for finding RTH, we should short the voltage source and open the current source. In this question, we have no current source, only the voltage source, so we're going to short it. When we short this thing, we get the circuit like this thing. RTH equivalent is equal to 5, 5 parallel to 4 plus 1. When we solve these two, this two answer will come in this side, and when this and this are series, so as usual 5 parallel to 4 plus 1. 5 parallel to 4, you get 20 by 9. Since it is parallel, reciprocating it, 9 by 20 plus this one is equal to 29 by 9. And here comes VTH 9I1 9I1 is equal to 36. This 4 and this 5, 4 plus 5 9. Current is equal to 36. I is equal to 4 amps. So current coming here is equal to 4 amps. And in VTH, since no resistor is here, what voltage flows in this resistor, the same voltage flows in here too. So when we find the answer for this resistor, the voltage, it's same as for this one. So it's easy, and R1 is equal to 4, and we got the IO is equal to 4. Voltage for R1 is equal to 4 into 4, 16 here. That's all for today. This question, with this question, we are going to find. Thank you guys.